Hi there, welcome back. In this video, we are going to learn about our typical approach of reversing the APK, understanding the source code, modifying the code to an extent, and patching the application without changes. Because as a pen tester, you will be required to do this process a lot of times. So let's directly jump into it. When we start learning the Android application hacking, the road to our destination looks something like this. But hang on, there is absolutely nothing to worry about. If you follow the approach and keep practicing, we'll be proficient in Android hacking soon. So in this video, I'm going to explain a typical approach, a step-by-step guide that you could take whenever you are pen testing an Android application. So first step is running the application to see the normal behavior. So for this, you need to have a test device or a Genymotion wherein you can install the application and run it. So previously in this course, we learned that how to download the APK from various sources. Now in this step, we are going to run this downloaded application into our test devices. What else we do in this step is we analyze the application to check the functionality. Like, is there a registration screen present in the application? How exactly the login is happening? Is the login is happening using email address and password combination, or is it with the mobile and OTPs? Based on this gathered information, you can prepare possible threat scenarios. For example, if there is an OTP based authentication, you can try to brute force the OTPs. So that's one example. Now once we run this application to see the normal behavior, what should be our next step? So our next step should be reversing the APK file. Now we need to take things apart to see what is happening. This will involve running several tools. The first tool that is general, people use it very often, is the APK tool. You can use APK tool to decompile the application. Similarly, there is a tool called JetX that gives you a nice GUI to play with, and that pretty much does the similar job. You can feed your APK and it will reverse and give you the source code. Now what we are generally dealing with is an APK file. So it is nothing but an archive written mainly in Java, Kotlin. So the programming languages are Java or Kotlin, and the views are typically created using XML. The APK has multiple entry points such as an activity, services, intents, content providers, etc. So until this point, you might not have reversed the APK ever, but in this video we are going to learn it from scratch. So first step you should do is you should use this CLI tool called APK tool and you should give the D flag. So D stands for decompile. Now our application name is reactor.apk. So what we are doing is we are decompiling this APK in order to check what it holds. So we are also going to look at the components of the APK in next few slides. So if I open this APK using a simple zip extractor, what we are going to see is the following folders and files. So let's look at them one by one. The first one is the Android manifest.xml file. It contains your package name, declaration of your app components such as activities, services, broadcast receivers, and content providers. It has permission that what this app can do once it is installed on your phone. What is the minimum system version, meaning what is the minimum Android version required to run this application, and what is the target SDK. So what is the target Android version for which the application has been built. Now one more thing you can see is the classes.dex. Now it is a compiled version of Java source code that is compatible to run Dalvik virtual machine or on the Android runtime. So ART is used since the Android 4.4 version. Similarly, we have lib folder. So lib generally contains the SO file. These files are written in C or C++. So these are native libraries that could be used in the target application. Next, we have the folder that is Meta INF. Now each Android app is signed with a developer certificate, and the Meta INF folder contains information about the developer of the application. The files inside Meta INF folder help in determining the integrity of the application. Last, we have RES, that is a resource folder. Now this folder contains all the resources like activities, XML files, images, and custom styles that is used in the APK. So these are the general components you will see once you open up your APK using any extractor. Now what happens in backend whenever you reverse the application like your APK, what happens in the backend? So these are the phases of Android reversing. Now once you extract your APK using APK tool, you will get these files. These are resources.rec, the classes.dex, and Android manifest that we have seen in the previous slides. Now classes.dex is the actual executable binary that your Dalvik VM or ART understands. Upon reversing this using dex to class, we get jar files. So we can use dex to jar tool to achieve this, and with bytecode viewer or JADX GUI we can open this in Java files. But when we do this process, a lot of information is lost in the conversion, so we don't get the exact Java code that was built when the developer was actually developing the application. So a lot of information is lost in this transition from compiled X code to Java. So let's understand this a little deeper in next slide. So when a developer create an application, so they write the code in Java or Kotlin, and the compiler creates in the DEX bytecode, which the platform actually understands. But as a reverse engineers, our job is to do the exact reverse of this process. So what we are going to do is convert the DEX bytecode to something called Smali, and upon reversing it, it will give us the decompiled Java. So instead of the Java code being run in Java virtual machine like the desktop application, in Android the Java is compiled to Dalvik executables, that is your DEX bytecode format. And if developers write in Java, the code is compiled to DEX bytecode. So to reverse engineer, we work exactly the opposite direction. Now what is Smali? So that is something new that we are seeing in this slides. So Smali is a human readable version of Dalvik bytecode. Now if you have done some sort of reverse engineering or computer architecture on compiled C or C++ code, you can relate the Smali to the assembly language. So it sits between the higher level source code and the bytecode. But in reality, Android platform doesn't know what Smali is. It is there to make our life, like the pen tester's life, easier to play with the Smali code and modify the logic of the application, because we can't really modify the Java source code as it is not the exact that developers have created. So whenever we are dealing with this sort of scenario, we need to understand the Smali, the corresponding Smali for Java, and then we have to make our changes in Smali code to achieve whatever we are targeting for. Now let's go to the next step. So once we reverse it to Smali and decompile Java, our job is to analyze the source code. So in this step, we try to understand the application logic and try to identify flaws. So we typically find out responsible activities, classes, methods just by searching in the JADX tool. We can also identify the type of application. It could be a native or hybrid application. We search for activities and class names, like if the encryption is happening at the client side and you intercept the traffic using Burp Suite, all you see is a ciphertext. That means that your application is encrypting the HTTP traffic and sending it to server. Then your server is going to decrypt it, and vice versa. So in similar scenarios, you will find the application encryption logic after reversing the code. You'll find the algorithms responsible for that encryption, and you may also find the keys. So how it actually looks. So let's look at this in the next step. So this is a screenshot of a JADX GUI tool. So what I have done is I've opened this APK. So this was a CTF APK. So it is a simpler example. It was built with Kotlin, as you can see here, and I have navigated to the main activity. So similar screen you will see once you open up your APK in the JADX GUI. Now if you look at here, there are two tabs. One says code and one says Smali. So this is a Java representation of the code that we have seen in previous slides, and we will also have the corresponding Smali for that. So the Smali looks something like this. So at first you won't be able to make much sense out of this, as this is a assembly language. So in this video we are going to learn about a Smali in little depth. So little about Smali. As we have discussed already, when we create an application code, the APK file contains a DEX file which contains binary Dalvik bytecode, and this is the format that the platform actually understands. However, it's not easy to read or modify binary code, so there are tools out there to convert to an human readable representation, that is Smali. And the most common human readable format present is the Smali. So in our academics, we must have seen this function if we learned Java. So there is a simple method, a public method named print hello world, and when you compile and run this with Java, it will print this string hello world. So this is the first program that we learn. Now if you are familiar with Java, this looks very familiar and easy to you. But what if we see the Smali representation of same code? Sorry. So here is the Smali representation of the same function we saw in previous slide. At this point, we have a lot of questions, like what is this dot method, what are registers, what is this asGet objects, and so on and so forth. So let's try to understand each component one by one. So we have registers in Smali. Now registers are a high-speed memory storing units. It is an element of the computer processor. It can carry any type of information, including a bit sequence or single data. So in Dalvik bytecode, we also have registers. So these registers are used to store information. Now typically these registers in Dalvik bytecode are of 32 bits and can hold any type of value. If you want to store 64-bit types like long and double, we should use 2 registers. Now how can we specify the number of registers in the method? Because in previous example we have seen that there was registered mention, like register 2. So how can we actually specify the number of registers in a method? So there are actually two ways of specifying how many registers are available in a method. So these are the two ways, either with the registers.register directive or with .locals directive. So the .register directive specify the total number of registers in a method, while the alternate .locals directive specify the number of non-parameter registers in a method. The total number of registers would therefore include the register needed to hold the method parameter. Now, how method parameters are passed into a method. So whenever a method is invoked, the parameters to the method are placed into the last n registers. So if your method has 2 arguments and 5 registers, like v0 to v5, these are 5 registers. So the arguments to the method would be placed into the last 2 registers. Those are your v3 and v4. Now the first parameter to a non-static method is always the object that the method is being invoked on. For example, if you have a method that you are writing to a non-static method and it has 2 integer parameters, but it also has an implicit myObject parameter before both the integer parameters. So there are total 3 arguments to the method. So let's say you specify that there are 5 registered in the method with the directive .registers 5, or you can do .locals 2. So that is your 2 local registers plus 3 parameter register. So when the method is invoked, the object that the method is being invoked on, that is your this reference, will be in v2, and the first integer parameter will be in v3 and the second integer parameter will be in v4. If you want to understand this in a little depth at your own pace, you can go to this URL. Now there are 2 naming schemes for registers, the normal v naming schemes and there is p naming scheme. So p naming scheme is for the parameter registers. The first register in the p naming scheme is the first parameter registered in the method. So as you can see, it says the first parameter register. So let's go back to the previous example of the method with 3 arguments and 5 total registers. So this table shows the normal v name for each register, that are your v0 to v4, and followed by the p name scheme. Now while referencing to the parameter registers, you can use either of this naming convention. You can call it by v2 or p0, it will make no difference. So this naming scheme is to just make it, modifying the method a little more easier. After registers, in this Mali we have data types. So Dalvik bytecode has 2 major classes of types, primitive types and reference type. So reference types are objects and arrays, everything else is primitive, as you can see in here. So when you see these letters in Smalley code, it actually means the corresponding data types mentioned in this table. So if you see v, it means void. If you see z, it means boolean, and so on. If you want a little more understanding of this data types, you can go to this URL. Now back to our example of hello world in Smalley. So let's try to understand this function line by line. So here we have a public method called print hello world. There are no arguments, as you can see in this braces, and then the return type is void because there is a v mentioned here. Now this method has 2 registers, So it is mentioned here dot registers 2. It means this entire method has 2 registers. Now we are calling instruction as get object and storing in v0. So v0 is our first register. What we are doing is we are copying from Java lang system, and there is a member called out of the type Java print stream. We are calling a static member out from Java lang system, and we are putting it into v0. In this line we have a constant string, so we have used the instruction const string, and we are storing the hello world string in v1. So this v1 is our second register. Now to call method, we use invoke instruction. So as you can see, invoke virtual. So we are using invoke virtual for calling the method, and now here the v0 is this because it is a non-static method. And the instance of system out, we are calling the println method. So in the instance of system out, which was v0, we are calling the println method, and we are passing one parameter, that is our v1. So print stream should take v1 as an argument, that is our string, and it should simply print the statement. Now it returns nothing, so it has v because it stands for void, and our method is also returning void because we have mentioned v here. So this was the Smiley representation of the simple hello world method in Java. So with practice, once you get familiar with reading a lot of Smiley, you will be proficient. So now let's look at the next slides. So as we have discussed, invoke instruction is used to call the method. So we have different version of invoke instruction here: invoke virtual, invoke super, invoke direct, invoke static, invoke interface. So this was a little intro about Smiley. Now what is our next step? So now we need to make changes to the code and patch the application with our changes. So that is called our modded APK. So what we need to do is we need to change the Smiley code to change the application behavior, maybe putting a logger function inside it, maybe changing the encryption logic, changing the decryption logic, whatever we have to do. Now once you modify the APK, sign it with your certificates, then comes the next step. So next step is, whenever you are trying to learn this, you will fail a lot of times because your application will crash just like this, but you should not give up. You will fail a few times before you get it right, and if you keep working, onwards the greatness. So after the last step, you will get your application working very smoothly, and you will achieve whatever you wanted to achieve with the application source code. These are few tools that we personally use and has already been discussed in last few videos. So that is ADB, APK tool, Genymotion, JetX, and MobSF. Now whatever the process we have seen in this video, let's try to understand with an example. So there was this CTF, NAMCON CTF 2022 that I have participated in the past. So it had a challenge that I am going to explain, and we are going to follow the steps that we have discussed. So let's jump into it. So there was a challenge, click me. It said I created a cookie clicker application to pass the time, but there is a special price that I can't seem to get. So let's download this APK, clickme.apk, and run it with our test device. And I saw this screen wherein the cookies count was 0 and there was a button. It says get flag, nothing much. So I clicked on this button and I got this message. you do not have enough cookies to get the flag. So now we have run this application to see the normal behavior. Next step is to reversing the APK. So to cut it short, I have opened this APK in the JetX GUI. So it looked something like this. So there was one activity, so I have navigated to main activity, and all the focus was in here because there was only one activity. Now as I scroll down to the main activity, it has two functions which are of our interest. So interesting function number one is get flag button click. So this function was getting called whenever we are clicking on that button, get flag button. So according to this function, we need to click the button this many times to get the flag. So if we are able to reach to this number, a toast will appear with the string that is calling the get flag method. So our target is to get this flag, but if this click does not matches with this number, you will get this message that we have seen in the previous slide, that you do not have enough cookies to get the flag. Now there was one more interesting function before that previous function. Now this function is calculating the clicks on get flag button, but if we look at the if condition, it will not let us surpass the click counts from this number, because as soon as our click counts are greater than this number, it will reset the clicks to back to this number. So it is a never ending condition even if we decide to sit and click on the buttons for hours. So certainly we are not going to do that, but what is the easy way out? So this is a Smiley representation of the same activity, main activity. Now there could be multiple ways to solve this challenge, but for this example we are going to solve it using Smiley. So let's go to the get flag button click method in the main activity. So here is the Smiley representation of get flag button click method. So few things we understand, that it returns void, it has 4 registers, it is calling so and so method, it has constant string where this number is stored, it has a if condition, because we have now a little idea about Smiley, so we can make a little sense out of this. And there is this string, it says you do not have enough cookies to get the flag. Moving forward, going back to our Java representation of get flag button click method, the if condition says that button should be equal to this number to print the flag, or you are getting you do not have enough cookies message. Now technically this get flag method can be called from anywhere inside this method. So what if we place this method, the invocation of this method get flag, over here? So we replace this string with this method, because anyways this is returning a string, so it should not be a problem, and even if we fail this condition we will get the flag. So that is our target. So technically we want to do this, in the place of this message we want to put the get flag method, but we can't do this in Java, so we'll need to make the exact changes in Smiley code. Now to modify the Smiley code, we'll have to decompile the application using APK tool. So this is the command for that, APK tool D and your application name. So once you decompile, you need to open this main activity.smiley using your favorite text editor. Now jumping to that method, there is a constant string, the register name is p1 and it has this value. Now, and this is the method toast method which is being called. If you see here, we are passing p1 over here. It means that this toast, the message, the little message that we are seeing on the screen, will have this message. So the string is getting stored over here p1, and p1 is passed into this method invocation. Now our goal is to replace this p1 register with the result of getFlag method. Now how can we do that? Let's see in the next step. So we will add the following line to call the getFlag method. So we will invoke this this method, getFlag method, with invoke virtual instruction, and we are going to store the output into p1 register. So for that we need to use move result object p1, and lastly we need to comment the line which is adding the predefined message to p1, and the rest of the code we will going to keep it as it is. So coming back to the method, we have added these two lines. So we are calling this getFlag method because we can call it from anywhere in this entire method. So we are calling the getFlag, and we are storing the result into p1. So now we are commenting out this string, and once this toast method is called, it has p1. So now in place of printing this message, it is going to print the output of getFlag method. So the changes are done. The next step is to patch the APK. So if we go back to Java representation, we have achieved this because we have replaced this error message with getFlag in the Smalley code. So now let's build the APK. So for that you need to use the B flag of the APK tool, and you need to output into a new APK. So that is your c.apk. Now before you can run it on your device, you need to sign it with APK signer and your certificate. So I am signing the APK using my certificate. I am installing this modified APK into the device. So again we are back to the screen where we are actually seeing the same things that we saw before. Let's click on the getFlag button, and here as you can see the flag is being printed. Now you can watch this video multiple times if you have not understood anything, but this is a simple example how we can modify the client side code like your Java or Kotlin code using Smalley. So, and this is a typical steps that any pen tester follows in order to make changes and create modified APK, bypass, validation and stuff like that. So I hope you have learned something new in this video. Thank you everyone. See you in the next one.